So now we want to look at that partial fraction decomposition again, but here we're going to have some repeated factors. So again, our overall goal with partial fractions is to take this rational function that we have and split it up into the terms of its denominator and as separate fractions for sort of each piece of the denominator. So that if we got a common denominator and added our individual fractions back up, we'd end up with this nice combined fraction. So what we're going to do is literally pull this apart and say we used these 2, 3, or 4, depending on how many we need, fractions. We added these together to get this nice combined function. So our process for this is always the same, and we always start by factoring the denominator. So that's going to be step number 1 that we've got. We're not even going to care that the numerator has got, a quadratic in it at this point, but we're going to take this denominator and factor it. And I noticed that there was a common factor of x squared, so I factored that out, and that was pretty much it. Okay. So then writing the partial fraction decomposition, what that entails us doing is again taking each of these pieces that we have in our denominator, so each of our factors, and rewriting our rational function as the sum of smaller fractions, which with each of these factors down below. So this video specifically here, we're doing something that's got a repeated factor. That x squared here is a repeated factor. And we do this whether our repeated factor is an x, or if it was x minus 2 that would be there as a factor 2 times. And basically what we're saying is that it's there as a factor more than once. We've got x times x. So we could write this out, and sometimes this is helpful to do, is to write this out as x times x minus 2. And so when we've got a repeated factor, we need to put that factor as a fraction 1 time, and then we're going to also put that as a factor squared. If it was, a factor, if it was x cubed, we would actually have another one with x cubed. We'd have to put it there as many times as it's a factor. So this one's a factor 2 times. So it's going to be in that denominator twice, once as a single factor and then once as a squared factor. And then we've got our x minus 2, that's only a single factor, so it's just there once. And then we're going to have some numerators here, and that's what we need to figure out what these are going to be. So again, the idea is that we've pulled apart this fraction, this rational function that we have, and we're going to pull it apart into a bunch of different smaller fractions that will give us this common denominator that we have as well. And our common denominator is our x squared minus 2x. So now when we've got this, clear the denominators, because we've got to solve for this a, b, and c. That's what we want to do. So I'm going to take this part right here because I don't want to write it again. And I'm going to copy this and I'm going to paste it down here. And we're going to clear our denominators, and we're going to do that with our common denominator, and our common denominator is always going to be this original denominator that we've factored. So that's what we're going to multiply through by. We're going to multiply all of our terms by this common denominator. And in some of the cases, we're going to cancel some things. Some of the cases, we're going to cancel a lot of things. But we're going to see what we have left. So each of our terms, things are going to cancel at least so that our denominator fraction cancel. And on our left-hand side, our fractions will cancel completely. And here on our right-hand side, here one of those x's is going to cancel with our 1x on the bottom. Here our x squared is going to cancel with our x squared. And here our x minus 2 is going to cancel with our x minus 2. So if we then take a look at sort of what we have left on each of our fractions, on the left-hand side here, we have x squared minus 2x minus 4, and I do apologize if you're hearing the dings. As always, I always get text messages when I'm making videos. So we've got x times, or a times x minus 2, because again, only one of those x squareds canceled with our x on the bottom. Then plus b times x minus 2. and plus c times x squared. And so again, what we're trying to do is we need to figure out what a, b, and c need to be so that when we do all of this distributive property here, so all I'm doing is multiplying ax through times our x minus 2 and multiplying our b times our x minus 2. And I left off a b right there, and then plus squared. So what we want to do, again, like I was saying, is we want to figure out what does capital A, capital B, capital C need to be so that when we combine our like terms, we get this quadratic that we have sitting here on the left-hand side. So when we add together our x squared terms, we want a coefficient of 1. When we add together any terms that have an x, we want to get a coefficient of -2. When we add together any of our constant terms, we want to get -4. So this is us solving for the coefficients. That's where we are now. So I'm going to undo that because what I want to underline is to get x squared, we would get that term from adding ax squared plus cx. So that gives us one equation. And again, our coefficient there is 1. And so what we need when we add a plus c, we need to get 1 as our coefficient. So 1 needs to be equal to a plus c. Let's grab another color here. -2x, we're going to get that from doing our -2ax plus our bx. And we'll do that in green. So -2x needs to be equal to -2ax plus bx. Or again, kind of rewriting this a little bit, that -2a plus b, whatever those coefficients are, when we add those together, we need those to be equal to -2. So we need -2 to be equal to -2a plus b. And then our constant term, -4, well, we only have one term left. That's going to be equal to whatever -2b is. So now these three equations that we have, this is a system of equations, and we can use these to solve for a, b, and c. So we have 1 is equal to a plus c, -2 is equal to the -a plus b, and then we have -4 is equal to -2b. So again, we're trying to figure out what are these coefficients that we put on these fractions up here to get us equal to our simplified fraction. All right, so that's again what we're trying to figure out. So I'm going to take this first equation right here that only has b in it, divide both sides by -2, and get that 2 is equal to b. So like we're a third of the way there already. And now we can use this and plug it into the second equation because -2 is equal to -2a plus b. So -2 is equal to -2a plus 2 because b is 2. Maybe we'll underline that with a highlighter. So b is 2. And then we can solve this for a. So we can subtract 2 from both sides. So we get -4 is equal to -2a. And shock of shocks, we get a is also equal to 2. And that can happen. You can get some of the coefficients being the same. And now that we know that what a is and what b is, we can now figure out what c is. Because c is equal to 1. Well, 1 is equal to a plus c. A is 2, because we just figured that out. And plus c, and then we can subtract 2 from both sides. So we get -1 is equal to c. So what did we figure out? So back up here, that a, b, and c, oops, oh, nope, go back. Always trying to do things too fast. All right, maybe we'll be a little more careful about what we copied to. So let's copy that, and we'll paste it right here. So we were trying to figure out a, b, and c, these coefficients on the tops of these fractions. So we figured them out. A was 2, b was 2, and c is -1. So if we got a common denominator and added these three fractions together, we would absolutely get x squared plus or -2x minus 4. And so, you can absolutely do that. You can check it if you want. You can take, 2 and our 2x and multiply it by x times x minus 2 on the top and the bottom. You can take our second term and multiply it by x minus 2 on the top and the bottom. And then you can take this last term and multiply it by x squared on the top and the bottom. And what you're going to get is you're going to get 2x squared minus 4 plus 2x minus 4. Oops, minus 4x right there. Sorry, lost a term there. And we have our common denominator. And so we get x squared minus 2x minus 4 over our common denominator. So we did actually figure out, what three fractions was it that we added together that gave us this rational function. And again, the reason why we do this is because this function, the way that it's written, we cannot take its integral. But if we take and write it in its split up form that we just figured out, and this is called the partial fraction decomposition, so 2 over x plus 2 over x squared minus 1 over x minus 2. Now, each of these three individual terms, we can easily take these integrals. Here, let me get my handwriting a little better. So we get 2 times 1 over x dx plus 2 times the integral of x to the negative 2 dx, and then minus the integral of 1 over x minus 2 dx, and we get 2 times the natural log of the absolute value of x plus 2 times negative 1, x to the negative 1, because that one, it's not a natural log because our exponent's negative 2, so we can use our power rule, and then minus the natural log of x minus 2 plus our constant, and we pretty much have it. We can kind of rearrange this a little bit to maybe make it a little bit nicer looking, put our natural logs together if we wish. But there we have it. And we've now, by again doing this partial fraction decomposition, we've turned our function into something that's pretty easy for us to take the integral of.